Hello, everyone. My name is Taehan Kim, and I'm a junior majoring in mechatronics engineering. Welcome to my presentation. Today, I will talk about CAN communication as the topic of my presentation. In this presentation, I will cover the definition and structure of CAN communication, explain the setting required to use CAN communication, and describe how to apply this setting to an STM board. Finally, we will have a Q&A session to conclude. First, I will explain the definition, features, and advantages of CAN communication. The controller area network bus is a high-precision serial bus system that connects intelligent devices in a network. It enables multiple ECUs to communicate by connecting them in parallel to exchange data. This system is widely used in various fields, such as automotive applications and industrial automation. Next, let's look at the features and advantages of CAN communication. CAN communication offers excellent reliability and durability. It also has a simpler structure compared to other communication methods. Additionally, it uses broadcast communication and has the ability to prioritize messages based on their IDs. Moreover, it features advanced error handling capabilities and operates with a multi-master structure. On the right, you can see a table comparing the features of CAN communication with other communication methods. CAN communication has a unique characteristic. It requires 120 ohm termination register at both ends of the signal lines. The reason for this is that without the registers, impedance mismatch can cause some signals to reflect at the ends of the bus. These reflections may lead to interference, which can result in communication failure. To prevent this, termination registers are necessary. Next, let's look at the structure of the CAN frame created by the CAN controller. CAN communication has two types of frame based on the identifier bit length, standard type and extended type. One important feature is that the smaller the identifier value, the higher its priority. Additionally, errors can be detected using CRC bits. Second, I will explain the setting for CAN communication. The first setting is the communication speed. In CAN communication, the speed is determined by configuring the time for 1 bit. This involves deciding how many time quantum virtual units are allocated within 1 bit time, which sets the transmission time per bit. An important factor here is the sampling point. The sampling point within 1 bit time is typically set to 75%. This is crucial for communication stability. If the sampling point is not properly adjusted, timing mismatches with other nodes can occur, leading to communication errors. The next setting is the communication filter. There are two filter modes in CAN communication, filter ID list mode and filter ID mask mode. Filter ID list mode allows only specific IDs to pass through. Filter ID mask mode allows IDs within a specified range to be received. Since CAN communication is often used with multiple devices, mask mode is generally preferred for its flexibility and handling a range of IDs. Next, I will explain how mask mode works with an example. Let's say the filter mask ID is set to 0x7f3 and the filter ID is set to 0x106. The binary representation of these IDs is shown in the diagram below. In the mask, a bit with a value of 1 indicates a bit that must be compared, while a bit with a value of 0 indicates a bit that can be ignored. Applying this logic to find the receivable IDs, we can see that the valid IDs are 0x102, 0x106, 0x108, and 0x10E. Any other IDs will be filtered out and cannot be received. Now, finally, let's look at how to configure CAN communication settings in STM32Cube IDE. First, check the clock speed of the CAN peripherals. Then adjust the number of time quantum to match the desired communication speed. A recommended parameter is automatic bus of management. ABOM is a parameter that automatically handles error states on the CAN bus. When set to enable, it automatically manages both errors. This concludes my presentation on CAN communication. Thank you. Thank you for listening to my presentation. If you have any questions, please feel free to ask.